Good evening, dear daughter and classmates. We are the Group 1 and my name is Li Lingyun. My group members are Ding Jiamin, Ma Jinming, Jiang Ziyi, and Li Shuanghui. Today I'm honored to introduce the topic 3, data collection and analysis. Our presentation will be divided into 5 parts: impact measurement, sampling and methods, data collection and analysis, case studies, and conclusion. Firstly, I start with the part of impact measurement, which is crucial for the evaluation, improvement, and optimization of educational innovation projects. I will conduct an in-depth exploration from two aspects: the definition of impact measurement and its importance in education. Impact measurement refers to the systematic evaluation of the actual effects generated by educational innovation projects. These impacts can affect the students, teachers, instructional content, and the school environment, and even the entire educational system. We are not only concerned with whether the project achieved the expected outcomes, but also with understanding the project's effects across multiple levels and dimensions, such as cognitive, emotional, and behavioral changes. Essentially, impact measurement answers the question: has this educational innovation truly lead to positive and verifiable change? This requires us to not only assess the achievement of expected outcomes, but also to explore deeper level effects of the project. When conducting impact measurement, several core elements must be considered. First is clear objectives, where the expected impacts must be set based on the research goals. Second is variable identification, where we distinguish between independent variables, dependent variables, and control variables. In order to clarify the impact pathways and understand the specific effects of educational innovations. Additionally, sample representativeness and the sampling strategies are crucial because they determine whether the measurement results can be generalized to a broader population. Moreover, data collection and analysis is a critical component, ensuring that both quantitative and qualitative methods are used to maintain objectivity and reliability in the results. Finally, results feedback and utilization involve offering data-driven insights to guide policy revisions, enhance practice, and foster ongoing improvements. Next, let's turn to the importance of impact measurement. First, validating the effectiveness of the goal achievement of educational innovations. The primary task of impact measurement is to validate whether the educational project has achieved its intended goals. For example, it can help us determine whether learning outcomes have improved, whether teaching methods have been optimized, or whether educational resources have been used effectively. Second, supporting evidence based on decision making and policy improvement. Impact measurement provides a data driven evidence base that helps education decision makers make informed choices. It clearly indicates which projects are worthy expanding, improving, or terminating. Furthermore, impact measurement supports the design of more targeted policies and interventions, helping optimize resource allocation and increase the efficiency and the effectiveness of educational policies. Third, promoting educational equity and inclusiveness. Impact measurement helps analysts the difference in benefits across various groups and encourages precise interventions and personalized strategies. Ultimately, it promotes equitable educational opportunities and overall improvement in educational quality. Fourth, strengthening the scientific and systematic nature of educational research. Impact measurement relies on scientific research methods, such as identifying variables to clarify causal relationships and using appropriate sampling to enhance result reliability. These scientific methods help contrast deeper educational theories, validating the effectiveness of various educational theories and methods. Lastly, enhancing public trust and project transparency for educational innovation projects funded by public resource or societal support. Transparent impact management reports help build public trust and support. These reports demonstrate the value and outcomes of the project, attracting more collaboration and investment. To sum up, educational innovations can only be sustainable and valuable for broader implementation when they are systematically and scientifically measured. Therefore, impact management is not optional but an indispensable core element in educational research and project implementation. Okay, that's all of my part. Thank you, everyone. Now, next, I'll pass it over to my friend Shuanghui.
Hello everyone, I'm Li Shuanghui. Just now we know about what impact measurement means and why it matters. Now let's think together. How do we know if a cause really make a difference? And how can we make sure our measurement is scientific and trustworthy? Today, I'd like to share with you three key steps. One, what to measure. Two, how to measure. Three, how to measure better. Steps 1. What to measure? There are three key dimensions of impact. First, learning outcomes, including test scores. For example, if students score 65 on a pre-test and 75 on a post-test, we might say they improved. But we have to careful. Maybe the post-test was easier. That's why we should also check other results, like unit tests or competition awards. Example, in a middle school math class, after using tiered assessments, homework accuracy rose from 80% to 85%, and the competition awards increased by 20%. Skill mastery is the second aspect. We can track project completion rates. Example, after taking an AI course at MIT, 80% of students passed, showing strong practical skills. Second, behavior changes. About the class participation, track, attendance, question asked, and contributions to discussions. About the outside activities, use the learning management system to check downloads, forum posts, and study group participation. Example, in one course, students download study materials 20 times on average, showing active learning. Third, long-term impact, career progress. Follow up 6 months after the course. For example, 90% employment rate and 70% positive feedback from the employers. Continue learning. Check performance in the later courses. Example, Stanford's design thinking course graduates started business at the rate 35% higher than their peers, with 20% higher company survival rates. Step 2. How to measure. About the collecting and analyzing data scientifically. Quantitative comparison. For example, the pre-test and the post-test comparisons of setting up an control group and the experimental group. Example, in a history course, students with the new teaching methods completed 30% more projects than the traditional group. 2. Behavior tracking. Use LMS data to track learning patterns, logins, video views, downloads, phone activities. Use structured observation. For example, 1 point for asking questions, 0.5 points for active listening to turn behavior into more data. Third, there are Kirkpatricks for level models. Level 1 reaction. Use the surveys to measure the satisfaction. Level 2 learning. Use the tests to check knowledge and skills. Level 3 behavior. Track whether students apply their skills on the results as the long-term outcomes. Okay, the model is very important. Next, let's see how to measure better. Address the common challenges. First, challenging 1. External interference. Students have different backgrounds, like prior knowledge of support networks. To fix this, we can use random group assessments or adjust for a variable like GPA when analyzing the data. For example, in a language course, the researchers controlled for students' original English levels to make results more accurate. Second, challenging 2. Difficulty of long-term tracking means students may lose contact after graduation. We can partner with alumni office or job platforms and office certificates to encourage them responses. Challenging 3. Subtle bias. In general, self-reports or teaching reteaching can exaggerate results. Solution to combine test scores, behavior logins, and independent experts reviews. If all 3 sources agree, the findings are much more trustworthy.
Hello everyone, I'm Jamin. Now I will introduce the types of sampling to you guys. First, let's define sampling. Sampling is the process of selecting a part of individuals from the population for research. In actual research, we often face various resource constraints, such as time, manpower, and material resources. So it's difficult to study the entry population. Sampling is like taking a scrub of water from the ocean to understand the water quality of the ocean. For example, if we want to understand the income level of residents in a city, it's impossible to survey every resident. But by sampling a part of the resident for investigation, we can infer the income status of the entry city. So, what's the purpose of sampling? First, sampling can obtain representative data under limited resource conditions. We cannot study every individual, but as long as a reasonable sampling method is adapted, we can ensure that the selected sample can reflect the characteristics of the population. Secondly, sampling can improve the feasibility and efficiency of research. If you study the entry population, it may take a lot of time and energy, or even impossible, or in some cases, sampling can complete the research task in a shorter time and save period research resources. And next, we enter the stage of sampling method classification. First is probability sampling. Probability sampling is a scientific case sampling method that ensures that the probability of each individual being selected is known and equal. This one includes a variety of specific sampling methods, which I will introduce to you one by one. And the first one is simple random sampling. Simple random sampling is the most basic probability sampling method. Its characteristic is that every individual in the population has an equal probability of being selected. For example, suppose we have a list of all students in a class and want to select 10 students for a survey. We can use a short tree method. Write each student name on a small pieces of paper and put it in a box, then randomly select 10 pieces of paper. The advantage of this method is that it's simple to operate and it's suitable for situations where the distribution of population characteristics is relatively uniform and the differences between the nerds of population are small. And next one is stratified sampling. Stratified sampling is to divide the population into several non-overlapping subgroups or strata and then randomly select samples from each stratum according to a certain proportion. This method ensures that the sample can cover all level in the population, thereby improving the representativeness of the sample. For example, if we want to know the distribution of grades of students in each grade and class in a certain school, we can stratify them according to grades and class and then select some students from each grade and class according to a certain proportion for investigation. In this way, we can avoid the simple only include people with excellent grade or student with poor grade. Stratified sampling can ensure that the sample contains all levels in the population, has good representativeness, and has relatively small sampling errors. And next one is uh, systematic sampling. Systematic sampling is to extract samples from the population and at uh, certain intervals. First, we need to determine the sampling interval. That's the number of individuals in the population at which a sample is extracted. For example, a factory produces 1,000 products and we want to extract 50 of them for quality inspection. Then we can first calculate the sampling interval, that is 1,000 divided by 15 equals 20, and then start from the first product and extract a sample every 20 products. Systematic sampling usually requires shortening the population. This method can save time when the population is relatively uniform, but if there are uh, periodic changes in the population, it may cause sample bias. And next one is scatter sampling. Scatter sampling is to divide the population into several non-overlapping subgroups or groups, and then randomly select several groups to survey all individuals in the selected groups. For example, all administrative villages in a country are regarded as different groups, and several villages are randomly selected to survey all the farmers in their village. This sampling method is suitable for a situation where the differences is with the group are large and the differences is between group are small. The last one is multi-stage sampling. This is to divide the sampling process into multiple stages and use different sampling methods in each stage. Taking a large-scale market survey as an example, you can first stratify by region, then select several communities in each region, and finally draw samples in each community. This method is suitable for situations with a large overall school and many levels. Non-probability sampling selects sample based on the researcher's subjective judgment or convenience, and it cannot guarantee that the probability of each individual being selected is equal. Non-probability sampling mainly includes convenience sampling, judgment sampling, and quota sampling. And common sampling is to select the most accessible individuals as sample. This method is simple to operate and can save time and energy, but its disadvantage is also obvious. And the response representative representativeness of the sample may be poor. For example, we conduct a questionnaire survey on the street and randomly select passengers by as a survey of subject. This one may only be resident for of a specific area and cannot represent the intricity's resident population. Therefore, common sampling is usually only suitable for preliminary research. And judgment sampling is to select samples based on the subjective judgment of the researcher. Based on their years of experience and professional knowledge, researchers will select these individuals who they think are most representative of the overall characteristics as samples. For example, a market researchers want to understand the demand of high-end customers for a luxury product. He may choose customers who often buy luxury goods. For classification based on his own judgment. This sampling method can give full play to the subjective intuitive of researchers, but its disadvantage is that it is easily affected by the subjective bias of researchers, which leads to sample bias. And the last one is quota sampling. Quota sampling is to allocate sample quotas based on certain specific characteristics. Suppose we want to understand the attitude of customers of different genders and ages toward a certain product. We can first determine the quotas of each group in the sample based on the distribution of different genders and age groups in the population, and then select samples from each group. This method can ensure that the sample covers various characteristics in the population, but it also cannot guarantee the randomness of the sample. Next, our group members will analyze how to choose the appropriate sampling method to your guys. Thank you.
After understanding the different types of sampling methods, the next step is to choose the most appropriate sampling methods based on the actual research objectives, population characteristics, and the results constants. Choosing a sampling method is not a simple decision. It requires considering various factors. It is essential to recognize that every research project is unique and the methods you choose will shape the direction and the quality of your results. So, how do we make a choice based on these factors? In this presentation, we will explore the considerations when selecting a sampling methods. The effectiveness of a research study is closely linked to the appropriate selection of the sampling methods. A carefully selected sampling method ensures that the sample accurately represent the population, leading to more reliable and valid research findings. On the other hand, the poorly chosen sampling methods can lead to skewed results that do not truly reflect the population's characteristics. Sampling is the process of selecting a representative sample from a larger population in order to make inferences about the entire population. The choice of the appropriate sampling methods depends on three key factors: research objectives, population characteristics, and resources constraints. The first factor is research objectives, which determine whether we need to infer finding to the entire population or only to a specific group. Research objectives define the purpose of study and help us decide whether the findings should be generalized to a larger group or not. If we aim to understand the impact of an educational reform on all students, for example, then probably sampling is needed. These methods ensure that every individual in the population has an equal chance of being selected, making the sample representative. Probability sampling methods such as simple random sampling, stratified sampling, and cluster sampling are appropriate when generalizability is important. On the other hand, if the study focuses only on a specific group or subgroup, non-probability sampling methods may be more appropriate. Non-probability sampling includes methods like convenience sampling, purposive sampling, and snowball sampling. These methods are often used in exploratory or quantitative research. where the goal is not necessarily to generalize to a larger population, but to gain a deeper understanding of a specific phenomenon. Next, the characteristics and the heterogeneity of the population also influence the choice of sampling methods. The population may be diverse in terms of factors such as age, gender, social economic status, education levels, and geography location. And there are significant differences within the population. You may need to use more sophisticated sampling methods to ensure that the sample accurately reflects these differences. For example, if a population consists of students from different grade levels, genders, and academic abilities, stratified sampling may be necessary. In stratified sampling, the population is divided into distinct subgroups or streets based on central characteristics. A random sample is then drawn from each stratum to ensure that each subgroup is adequately represented. This is particularly important when the research aims to study specific differences between subgroups within the population. Finally, resources constraints such as time, budget, and manpower will also influence the choice of sampling method. If you have limited resources, it may not be feasible to use a probability sampling method, as these methods can be time-consuming and expensive. In such case, non-probability sampling methods, which can typically quicker and cheaper, may be more appropriate. For projects with limited resources, convenient sampling will involve selecting individuals who are easy to reach, may be an acceptable option. While convenient sampling offers lower representativeness, it allows for data collection in institutions where time and budget constraints are significant. However, it is important to recognize the limitations of non-probability sampling methods and understand that the finding may not be generalizable to the entire population. To better understand those factors, let's look at the field case studies. The first case, in an educational reform project, the researchers use simple random sampling to assess the impact of new teaching methods on student performance. Since the research aimed to infer the performance of all students, the researchers wanted to ensure that every student had an equal chance of being selected. By using simple random sampling, they ensure that the sample was representative of the entire student population, allowing them to make valid generalization about the effectiveness of the reform. The second case, in another project, the researchers used the stratified sampling. They divided the student into different streets based on grade level and gender. And the randomly selected sampling from each stratum to ensure the samples group proportions matched those of the population. This approach helped ensure that each subgroup, whether by gender or grade, was adequately represented in the study, allowing the researchers to examine whether the reform had different effects on different groups. The third case, due to limited resources, the researchers used convenient sampling. They selected schools that were easily accessible, such as those located near the researcher's office. While these methods have lower representativeness, it was feasible given the budget and the time constraints. The researchers were able to conduct the study within the available resources. but they acknowledge the limitations of their sampling methods and to care not to make sweeping generalization based on the findings. Once the appropriate sampling method is selected and the relevant data is collected, the next step is to discuss how to analyze the data. Data analysis is a critical step in the understanding the impact of educational reforms, as it helps us extract valuable insights from complex data. We will focus on two main methods of data analysis: quantitative data analysis and qualitative data analysis. Both of these methods are essential for evaluating the outcomes of the educational reform project, and they offer different representative on the data. Quantitative data collection tools are designed to measure objective variables and quantify data numerical terms. One of the most common tools is the survey. By designing satisfactorily structured questionnaires, researchers can collect data on various aspects of student performance, study factions, and more. Surveys can be distributed through online platforms, via email, or in paper format. The researchers can choose the most appropriate methods based on the research objectives. Another important tool for collecting quantitative data is standardized testing. Testing and exam allow researchers to measure student performance in a controlled and objective manner. By using reliable and valid testing instruments, researchers can assess student learning outcomes and determine whether the educational reform achieved its goals. Standardized testing should be carefully designed to ensure fairness and accuracy in measuring student skills and knowledge. Qualitative data collection tools aim to capture subjective experiences, perceptions, and insights. Interviews are one of the most commonly used qualitative methods. By conducting in-depth interviews with teachers, students, and parents, researchers can gain a deeper understanding of their experiences with educational reform. These interviews may be conducted face-to-face or the phone, or through online platforms such as video conference. In addition to interviews, classroom observation, or another valuable quantitative data collection methods, researchers can observe the teaching behaviors of instructors and the responses of students to evaluate the practical effects of educational reform in the classroom. Observations can provide insights that quantitative data cannot, such as how students interact with the new teaching methods or how teachers adapt their strategies. Okay, the next lecture will be presented by my teammate, who will introduce data analysis techniques. Okay, thank you for your attention.
Data analysis is the backbone of extracting meaningful insights from raw information, and it's essential for making informed decisions in various fields, from education to business and beyond. Data analysis can be broadly classified into two main categories: quantitative data analysis and qualitative data analysis. Both methods have their unique advantages and are used to address different research questions. Quantitative data analysis focuses on analyzing numerical data. It helps in describing, inferring, and predicting based on statistical information. Let's take a moment to explore some of the key techniques involved in quantitative analysis. Firstly, we have descriptive statistics. This technique helps summarize the basic features of a dataset. It includes mean, the arithmetic average of the data; median, the middle value of a dataset, often used to represent central tendency when data is skewed; standard deviation, a measure of the data spread or variability, showing how much individual data points deviate from the mean; frequency distribution displays how often each value occurs in the dataset. These statistics help researchers quickly understand the central trend and spread of data. Second, inferential statistics. Inferential statistics are used to draw conclusions about a population based on sample data. Common techniques include hypothesis testing, used to test if a hypothesis about the population is true. For example, assessing whether an educational reform has a significant impact on students' performance. Regression analysis. Analyze the relationship between independent and dependent variable, commonly used for prediction. Confidence intervals estimate the range within which a population parameter is likely to fall, assessing the reliability of the estimates. Inferential statistics allowed researchers to make well-supported prediction and inference based on sample data. On the other hand, qualitative data analysis is used to interpret numeric data. It is particularly useful when researchers aim to understand deeper insights into human behavior or social phenomena. Two common methods in qualitative analysis are semantic analysis and content analysis. First, semantic analysis. Semantic analysis involves in identifying key themes and patterns from qualitative data such as interview transcripts or observational notes. By carefully reading through the data, researchers can identify recurring themes, concepts, or viewpoints that help explain the core issues. For instance, in an educational reform study, semantic analysis of interviews with teachers and students might reveal challenges and opportunities brought about by the new teaching method. Second, content analysis. Content analysis is a systematic approach to coding and categorizing textual data. Researchers classify, tag, and count information from raw text, such as interviews, articles, or social media posts, to uncover meaningful patterns. Content analysis can involve both quantitative and qualitative assessment, allowing for the identification of themes and sentiments across different categories. For example, analyzing consumers' reviews on social media could reveal a brand's public image or highlight product strengths and weaknesses. Here are several case studies. The first case study, evaluating educational reform with simple random sampling. We choose sampling method is simple random sampling. We choose data collection tool is structured questionnaire and standardized test. Analyzed. The research aimed to evaluate the impact of new teaching method on student performance. Simple random sampling was chosen to ensure that each student had an equal chance of being selected, avoiding bias in participant selection. Data collected included quantitative scores from standardized tests and the response to questionnaires regarding students' satisfaction outcome. This method ensured that all students, regardless of grades or background, were equally represented, making the finding generalized to the entire student population. However, if there were significant variations in performance among students, simple random sampling might have overlooked specific subgroups that needed attention. Second case study. Impact of teaching method based on stratified sampling. We choose sampling method is stratified sampling. We choose data collection tool is structured questionnaire. Analyze. Researchers divided the student population into subgroups based on grade and gender. They then randomly selected participants from each stratum in proportion to the stratum size in the overall population. This method ensured that each subgroup was adequately represented in the sample, which was crucial for evaluating how the teaching method affected students across different demographic groups. Outcome. The stratified sampling method provided more reliable insights, ensuring that difference in teaching method effectiveness across grades and genders were well represented. The analysis revealed that different grades shows varying levels of improvement, highlighting the needs for tailored teaching approach for different age groups. The third case study, accessibility of data collection in resource-constrained setting using convenience sampling. We choose sampling method is convenience sampling. We choose data collection tool is interview with teachers and students. Analyze. In a study with limited resource, researchers opted for convenience sampling, selecting schools that were easily accessible in the local area. They conducted face-to-face interviews with teachers and students about their experience with the educational reform. While this approach saved time and money, the sample lacked diversity, primarily reflecting the views of those from local, easily reachable schools. Outcome. Although this method was cost-effective and time-efficient, the lack of diversity limited the representativeness of the finding. The results primarily reflected the perspective of a homogeneous groups, and the conclusion might not be generalizable to other schools outside the area. This approach was best suited for an initial exploratory study or for generating hypotheses rather than definitive conclusions.
Thanks for my friend's presentation. I'll continue with the part of conclusion. In summary, evaluating educational innovation projects requires a systematic approach to data collection and analysis. Impact measurement is crucial for assessing project success and ensuring results are generalizable through proper sampling methods. Researchers must define variables, use reliable tools, choose appropriate sampling strategies, and use quantitative or qualitative methods for a thorough analysis. Continuous feedback is also vital for ongoing improvements in policy and practice. As a result, data collection and analysis are not just technical processes, they are the foundation for making informed decisions that drive meaningful improvements in education. Okay, next, the reference mentioned in this presentation can be found on this page. So that's the end of our presentation. Thank you all for watching and listening. And any questions?